Hello everyone, today we will work on some exercise problem from this section 12.3. Actually, I look at these questions here. We have some questions that are quite interesting to go over, which I don't think I will go over in this video here, but I will try to set up some time and then create the lecture videos for to discuss this number 28. When I look at that question, I thought it's easy. It turns out to be not that simple, and it took me like 1 hour to get a better way to do that. But in between, I see that I actually have 3 different ways to do that. Okay, and then number 29 and number 30, I will go over that in these videos here. But I think more importantly, I will discuss a little bit about the pre-calculus way to do these problems. And then now in calculus 3, we have another way to do the problem. Okay, and then most of these here are just standard. I will also work on number 53. That's actually an interesting question. That gives us a formula, but we will be more interested in how to develop that formula. Okay, let's just start then. In this number, between 2 to number 10, of course, I will not do all of them because, especially because they are just a standard, right? Standard procedure. Find the dot product. So let's say I do number 4. Find the dot product of A and B, which is 6, -2, 3, dot 2, 5, -1. That will be the product of X components, that's 12. The product of Y components, -10. The product of the Z component is -3. So this will be -1. Quite easy, huh? How about number 8? Number 8. Notice that when they use IJK notation, then we don't do it like this, just like 2i plus j, right? That's for factor A. Now we don't write it this way. We don't write it as 2i comma j comma 0. No, we don't do it like that. The I itself is already a unit factor in positive X direction. In other words, the I itself is 100. And the j is 0, 1, 0. Okay, so putting things together, 2i plus j basically means 2, 1, 0. Okay, that's the notation. And then for what I'm looking at number 7 actually. Well, anyway, let me fix that. 3i plus 2j. Let me erase all of this. At least I explained to you the notation, right? Okay, so 3i plus 2j minus k, that is 3 to -1, while factor b, I will just translate it right away, that's 4, 0, 5. So the dot product will be the product of X components 12, the product of the Y component 0, the product of the Z components is -5, so the dot product is 7. Number 10, find the A dot B if we know the magnitude for each and the angle between them. Well, then we use the quote-unquote the physicist formula. Remember this formula? Okay, and then I will plug in numbers. Magnitude of factor A is 3, magnitude of factor B is square root of 6, cosine of the included angle 45 degrees. So this is 3 square root of 6 times 1 over square root of 2. That will be 3 square root of 3. Okay, now let's go on further. Some of the questions that I will go over here are very conceptual. For example, number 12. U is a unit vector. So this is a unit vector, which means the length is 1, right? The length here is 1. And as you can see here, this length U here, you see this notation, right? The tick there with this notation means they are the same length, they are congruent, right? In other words, all those has length 1. And because this is a right angle here, it basically make that figure a square with sides equals to 1. Now, if the length here is 1, then what is the length of factor W? The length of factor W is also 1, and the length of factor V is, so the length of factor W is 1. The length of factor V will be, I wonder if you can tell by just looking at that. If not, then think about it, right? Maybe I do it this way. If this is 1, then this will be radical 2, right? The diagonal of the square will be radical 2. Now, factor V has length half of that diagonal. Okay, so the length of factor V will be square root of 2 over 2. Now, furthermore, the angle between factor U and V is clearly, that's the diagonal of a square, that's 45 degrees. And the angle between U and W is 90 degrees. Okay, now, therefore, factor U dot factor V will be magnitude of factor U times magnitude of factor V times cosine of the included angle. That's 1 times radical 2 over 2 times cosine 45 degrees, which also radical 2 over 2. Okay, so this is radical 2 over 2 times radical 2 over 2, that's 2/4, which is 1/2. How about U dot V? Well, you can see that U dot W, you can see the angle is 90 degrees, and because these two angles, the angles between these two factors is a right angle, then the dot product must be 0. Okay, now of course you can do it long way using these formulas here, right? You can use that, but you will see that cosine 90 degrees is 0, right? Okay, so that's for number 12. So this question number 12 here is, they basically give you very little information, and you need to go on finding a lot of them through the geometric figure. Okay, now between number 15 to number 20, find the angle between factors. You will use calculator here, definitely. Okay, but for example, number 16. Number 16, the angle between factor A and factor B, let's call that theta, then cosine theta is the dot product of those factors divided by the magnitude of the product of the magnitudes, which implies we're supposed to find the length for each first. Okay, the length of factor A is square root of -2 squared and 5 squared, that's square root of 29. And the magnitude of factor B is square root of 5 squared plus 13 squared. Oh, we know that's Pythagorean triple, that's 13. Okay, so, one more. We need to do the dot product, huh? So A dot B will be -10 plus 60, which is 50. So cosine of the included angle equals to 50 over 13 times square root of 29. Now, when you do this question in my test or in my quiz, please write the exact value first, which is theta equals to cosine inverse of this guy. Okay, and if you give your answer in either in degrees or radian, give me 5 decimal places. Okay, give me 5 decimal places. So let me use my calculator now. Oh, my calculator, we have cosine inverse of 50 divided by the product of 13 square root of 29. That's 44.42127. 44.42127. Don't forget the degree sign. Okay. Now, likewise for number 20, they kind of like give a red color for that number 19. I don't know why, but I believe it's just the same way. Okay, like number 20, let's try if we have three-dimensional factors. That's 1, 2, negative 2. Oh, I think I can tell right away that the length is 3, right? Just 1 plus 4 plus 4 under square root, that's square root of 9. So the length is 3, and factor B, I, J, K. So the length is 5, huh? The dot product is 4 plus 0 plus 6, that's 10. So cosine of the included angle equals to 10 over 3 times 5, which is 10 over 15, that's 2/3. Okay, so theta equals to cosine inverse of 2/3. Yeah. Give me that give me that exact value first, and then go ahead if you want to use calculator. Okay, cosine inverse of 2 divided by 3. 48.18969. 48.18969. 18969 degrees. That's the approximate value. Okay, give me the exact value first, and then when you give the approximate one, at least 5 decimal places. Okay, let's go on. I usually don't go over odd questions, but I decide to do odd questions from number. I will do these 4 problems, but in these videos I will do 25, 26, and 27. Now, let's see number 25 first. I want you to figure out the idea behind this. You have 3 coordinates, okay, P, Q, R, okay, and you want to know if this is a right triangle. Now, of course, then an angle is a right triangle if one of the angle, let's call this angle P, angle Q, and angle R, either one of them is a right angle. Okay, but to show that we have a right angle, we're supposed to do dot product thingy, right? Okay, we're supposed to do dot product thingy. What we will do is let's create first the factors correspond to this. Let's say I choose to do this factor. Let's call this factor R because that's positive of angle R. Let's call this factor P because it's opposite of factor P, coordinate P, angle P, and let's call this factor Q. Okay. Now, what is factor p. Factor p, that's QR, right? Let's call that QR. That's QR, which means coordinate of r minus coordinate of p, or of q, I'm sorry. R minus q for -2, -1. Factor q, let's call that PR. That's R minus P, 5, 1, -3. And then factor R is PQ. Q minus R1, 3, -2. Now, we have a right angle if if we can find a pair of these two factors, of these three factors. If we can find two of them, we don't know which two, that give us dot product equals to 0. Okay. Now, of course, you can also say, oh, you know what? Let me choose this dot product here and find the angle, and dot product of QR, find the angles. If they add up to 90, then it's a right angle. If one of them is 90, then it is a right angle. Okay. That's those are your options actually. But I think what I will do instead is I will just do dot product. For example, P dot Q will be 20 minus 2 plus 3. That's definitely not 0. So between factor P and factor Q, that's not right angle. In other words, if we see factor P and factor Q does not form right angle, then we can say that this is actually not a 90 degrees. Okay, in fact, we can say something more. Because the sum here is more than 0, it means the angle at point R is acute. It's less than 90 degrees because cosine theta is positive in the first quadrant, right? Okay, is acute. I don't need to make that comments for this question, but that's just something we observe. And then, how about PR? P dot R is 4 minus 6 plus 2. Oh, this is equals to 0. So factor P is perpendicular to factor R, which means that triangle PQR is a right angle at point. You see, this is factor P and this is factor R. The dot product gives us 0. Then the right angle must be at Q, right? Well, then we are done. Yeah, we don't need to go further, you know. But in case this PQ and PR P dot Q, P dot R does not give us 0, then we try Q dot R. If all three of them does not give 0, then it's not a right triangle. Okay. Now number 26. Let me partition this. Number 26. Find the values of x such that the angle between these two factors is 45 degrees. Please catch this S here, which means there are more than one possible x. Okay, so we have, let's say that factor A, let's name that factor A for number 26, 2, 1, -1, and factor B be 1x 0. Now, then the magnitude of vector A is square root of 6, while the magnitude of vector B is square root of 1 plus x squared. Okay, the dot product A dot B is 2 plus x, right? Plus 0. Now, cosine theta is A dot B over the product of the magnitudes. Now, when I put those in, cosine of 45 degrees, yeah, we know that theta equals to 45 degrees, right? That's what it tells us. So cosine of 45 degrees is the dot product over the product of the magnitudes. This is radical 2 over 2 equals to 2 plus x over square root of 6 plus 6x squared. I will do number 27 to the left of this later on. Now let me go on. I will cross multiply, so I get square root of 12 plus 12x squared equals to 4 plus 2x. Now I will square both sides. Okay, I will square both sides. I get 12 plus 12x squared equals to 4 plus 2x being squared. I think I overkill this though. Yeah, there must be some common factor that I can reduce later on. But this 16 plus 16x plus 4x squared. Set one side equals to 0. You know what? Let me just go on to the right here. So that will be 8x squared minus 16x minus 4 equals 0, reduced by 4. Then I don't think this is, I will just use formula. So x12 will be negative b plus minus square root of b squared minus 4ac over 2a. That is 4 plus minus square root of 16 plus 8 over 4. That's square root of 24. That's 4 times 6, 2 square root of 6 over 4. Reduce a bit further. 2 plus square root of 6 over 2. Let me make sure I don't make miscomputation anywhere. I don't know the answer, honestly. I don't know the answer. But the procedure will be like this. Anything, if I make any mistake, it must be a computational mistake. But I think I'm okay. Yeah, I think I'm okay. So those factors are, those x's are either x equals to 2 plus square root of 6 over 2 or 2 minus square root of 6 over 2. Okay, now we supposed to check against, supposed to check against the original equation. Yeah, we're supposed to check against the original equation, but I think when you compute that, both of them will be okay. Yeah, both of them will be okay. When I put that mark, I actually refer to both of them. Yeah, you're supposed to check. Okay, check against the original equation. At least we see that square root of something has to be at least 0. So 4 plus 2x has to be at least 0, right? In other words, then x will be greater or equals to -2. Okay, which I believe is the case here. This is greater than -2. Okay, I think that's negative, but still greater than -2. Okay. Yeah, but check in full. Check in full. Maybe you use your calculator to confirm. Now, how about number 27? Number 27 is better than, let me put that comment first. This is better than using cross product faster. But can we do that without dot product? Well, let's see. Let V be a factor normal to I plus j. Now I plus j is 110. Now this V also normal to I plus k. Now the idea is I will find a factor like that first, and then I make it a unit factor. Okay, so once I find the phi later on, I will find a unit factor or factor phi to make it unit. But first, I will find the unit factor. Now, and phi, let's call that phi equals to ABC. Okay, now because phi is normal to 110, means the dot product should be 0, right? The dot product will be a, maybe I write it in more complete, phi dot 110 equals to 0. So we get a plus b equals to 0. Let's call this the first equation. From the second information, 101, we also get the same thing, similar thing, a plus c equals to 0, and call that equation 2. Now, from here, you notice that we have a system of equation with 2 equations, but 3 variables. Now, in this case, then we notice that one of them must be, we have infinitely many solutions for this. And one of them must be, we call that a free variable, okay? What they have in common here is RA. So let's solve from equation 1, b equals to -a, and from equation 2, c also equals to -a. In other words, our factor v is a, -a, right? And you can choose any numbers for your a, okay, as long as it's not 0, because once you make a equals to 0, you get a 0 factor, right? But you can choose any numbers. Now, of course, I just need a unit factor, right? Let's say a equals to 1. You will see that a equals to -1 also work, and that's just yeah, when a equals to 1, you will get another one factor. Another unit factor will be the opposite of that. So now your v, factor v is 1, -1, -1, but unfortunately the length is square root of 3, right? So the unit factor that we are looking for is 1 over radical 3, -1 over radical 3, -1 over radical 3. This is one of them. Okay. The other one will be the opposite of this factor. So the unit factor that we're looking for, if I rationalize the denominator, this is -radical 3 over 3, negative radical 3 over 3. Okay, now maybe a little comment. The another unit factor is negative of uv, which is negative radical 3 over 3 radical 3 over 3 radical 3 over 3. Okay, I can say that there are actually only two unit factors that are orthogonal to both. There are infinitely many factors orthogonal to both of these two factors, but only two of them unit. Now, but Thomas, you said earlier that you can choose any a you like as long as it's not 0. If you have so many a's, then we must have so many a lot of unit factors though. The answer is no. The answer is no, because if we actually go a bit further, if you want to analyze that further, notice that the magnitude of factor phi here will be absolute of a, the length of absolute of a, whatever a that you choose, but you make it absolute, square root of 3. Now, if you choose your a to be 1, then the length is radical 3, right? And you end up with this factor here. Now, imagine if you choose your a equals to 2. The length of that factor phi will be 2 radical 3, and the resulting unit factor will be the same. Okay, but when you choose your a to be negative, let's say negative 2, okay, then when you find the unit factor, you will get something look like this. In other words, it depends on the choice of a you make. If the a you choose is a positive number, then you will get the unit factor that we found in blue here, the one I underlined. And if you choose your a to be a negative number, then you will come up with this one here, this unit factor. Okay, now why I want to go over this question, it's because the fact that it's not unique, the unit factor in this case that solve this problem is not unique, but at the same time it's not infinitely many. Okay, so notice the technique I use. I first call that ABC. It turns out that I have one free variable. Therefore, because you have a free variable, then you can choose your free variable anything you want and find a unit factor. Okay, in other words, we are not looking for the unit factor directly. No, there's no need to do that kind of magic from the very beginning. And if you do so, it will be way too hard. It will be way too hard. Okay, so we find the factor first and then you make it unit length. Okay, next. Find the acute angles between lines. We actually learn how to do this problem in pre-calculus. Supposedly, you learn this question in pre-calculus. Okay, let me give you the idea. Pre-calculus method, which I will erase later on. Pre-calculus method. What we do is we solve each equation in terms of y, and then we look at the slope. So first equation, y equals to 1/2 x plus 7/2. The second question here is 5x minus 2. Okay, now in pre-calculus, we learn that the tangent of the angle is equal to the slope of the line. If you wonder about, oh, Thomas, I never know that. Okay, let's take a look then. So you see, useful for us to learn something, right? Okay, suppose we have a line. Suppose we have a line with slope like this. The slope is m. Which we will express as a over b. Let's call that a over b for now. Now you will see that the rise over run here will be a over b. So this is a multiple of a, this is a multiple of b, the same multiple of b with vector k, right? Such that the slope is ak over bk, which is the slope m, right? Which is a over b, which is the slope m. Now, but notice that the angle theta here, the angle formed with positive x-axis is equal to that tangent. The tangent of that angle equals to that slope. I hope you notice that now. Okay, so we can say, if I go back here, I hope you understand it with a very brief explanation like that though. But this is actually your pre-calculus teacher's job, not mine. Okay, so tangent of theta 1 is the slope of the first line. So theta 1 is tangent inverse of 1/2. If theta 2 is the angle formed between the second line and the positive x-axis, then theta 2 will be tangent inverse of 5, right? Now, apparently you can see that the slope of the first line, I'm sorry, it should be negative 1/2 here, huh? Okay, so the first line looks like this. So this is the angle, theta 1, right? And the second one looks like this. Okay, and this is the angle theta 2. Now, what you need, the angle theta that we are looking for is basically theta 1 minus theta 2. Okay, you can also do theta 2 minus theta 1, whichever gives you the positive angle, right? Okay, but from our sketch there, you see that theta 1 is larger. Okay, now let me use my calculator now just to get the answer. But this is not how I expect you to do it. Okay, so I will do tangent inverse of negative 1/2 close parenthesis minus tangent inverse of 5. Huh? Why is it negative number? Oh, I see. Oh, because if I use that, it will give me this angle. My bad. Okay, it will give me this angle instead. Yeah. Okay, that will give me that angle. Theta 1. It will give me negative angle. Oh, so just get the opposite of that then. Or we add 180 degrees because that's the period of a tangent. So that will be 74.74488. So theta is 74.44 74488 74488 degrees. Okay, we earlier get 105.25512 degrees earlier with negative sign, with negative angle. Okay, now anyway, that's the pre-calculus method. Let me just leave it there for now, and we will use our calculus 3 method to solve this and see if we get the same answer. Now, why I want to go over this calculus 3 method is because we have something more to learn also. Okay? Something important to learn. What I want to show you is the following. Let's say we talk about the first equation, x plus x plus 2y equals to 7. You can see the x-intercept is 7. The y-intercept is 3.5. So this is the line. Okay. And if you watch this lecture, these supplemental videos, I hope you learn something more than just my lecture. In my lecture, I teach what you need to know in calculus 3, right? But in my supplemental video, I want to teach you the relationship between what we learn in calc 3 and from what we learned in the past. Okay, for example, you may notice that that starting from your calc 2, when it comes to equations of a line, we tend to write it in general form instead of slope-intercept form. And the reason is actually because of the following. Okay, if you make this becomes 1 here, you will get x over 7 plus y over 7 half. This gives you the x-intercept. This gives you the y-intercept. Okay, as long as this is 1. As long as this is 1. That enables us to graph a lot faster. Okay, now just a little note though. Now, but what I want you to learn is actually not that one. What I want you to learn from here is as the following. If we see, this is actually x comma y dot 1 comma 2 equals to 7. If you rewrite that into dot product of two factors, and you want to notice that factor 1, 2, factor 1, 2, 1, 2, this factor here is actually perpendicular. This factor here is actually perpendicular to the line. Okay? Note that 1, 2, this factor here is perpendicular to the line x plus 2y equals to whatever constant. In this case, x plus 2y equals to 7. Why do we want that? Because of the following then. If I want to find the angle between two factors, what I can do is to find the angle between two lines. What I can do is to find the angle between the two factors perpendicular to those lines. Okay, so the second line looks like this, right? The slope is 5. I don't graph it. I don't graph that accurately. Let me try. Rotate that a little bit like this. Yes, 5, right? The slope is 5. And the y-intercept is 2. I don't need to be accurate anymore though. Now, what I want to show you is this, that the angle here, the angle between these two lines here is the same to the angle between this factor, the factor that is perpendicular to the first line, and this factor, the factor perpendicular to the second line. Okay. Just imagine that if you have two lines, right? And then you look at the perpendicular factors. This is the factor perpendicular to the first one, and this is the factor perpendicular to the second one. Notice that the angle here must be the same to the angle here. Okay, so angles between two lines is equal to angles between their normal factors. Yeah, normal factors refers to the factors normal to that line. Okay, if this is angle theta here, this is also angle theta. Now you will see that actually enable us to do this computation a lot faster and better. Okay, so let me erase this explanation. So only if you watch this video, you will learn something. If you just look at the PDF, no, you will not learn something. Okay, now I continue for the second equation. This line is perpendicular to 5, -1, right? Okay, so cosine theta equals to the dot product of those two factors divided by the length of those two factors. Okay, so theta equals to cosine inverse of, what is the dot product? 3 over square root of 130. Now let's use our calculator. So cosine inverse of 3 divided by square root of 130. I hope they're the same, right? Do you see that? But yeah, this is a lot faster. I don't even need to change those standard form of those lines, the standard equation of those lines, into slope-intercept form anymore. Remember when I did that? When I changed that into slope-intercept form, I happened to make a mistake on my slope. No, I didn't purposely do that though, but you see, it happens. It happens, right? Okay, now the key takeout from here, from this question here is, oops, I'm sorry. The key takeout from this question here, there are two. The first one is that if we rewrite that the equation of a line into dot product, you will see the factor here is normal to the line. Okay, that's one. Second, the angle between lines are equal to the angles between their normal factors. Okay, now, okay, so Thomas, it seems like you explained it, but at the same time, is it how you want us to show the work? Nah, cut to the chase. Okay, no, we don't do that. We don't do that. Let me show you how you're supposed to properly show your work in a nicer way, of course. Okay, let's do it this way. X plus 2y equals to 7 is normal to factor 1, 2. And then 5x minus y equals to 2 is normal to 5, -1. Okay, now the magnitude of 1, 2 is square root of 5. The magnitude of 5, -1 is square root of 26. The dot product is 5 minus 3, 2, which is 3. So cosine theta, which is the cosine of the included angle, is 3 over square root of 5, square root of 26. So theta equals to cosine inverse of 3 over square root of 130. Now this theta here is the same to the theta we have here. Okay, the angle between two lines equals to the angle between their normal factors. Okay, See, a lot shorter, right? Which we compute earlier. I forgot what's that. 74.7488 something. I forgot. Let me check my calculator. Give me a second. 74,744,88. 74,744,88 degrees. Okay. Again, this question are not the one I actually did in my lecture, but we learned something from there. Number 33 to 37, find the direction and angles of the factors. Well, this is just standard procedure. I would just do let's say number 34. Number 34. Direction cosines and direction angles. So direction cosines is cosine alpha, cosine beta, cosine gamma, directional angles, equals to the unit factor of that factor, which is 6, 3, negative 2 over the magnitude of 6, 3, negative 2. I think that will give us 7, 36 plus 9. 36 plus 9 is 45 plus 4, 49. That's 7. So that will be 6 over 7, 3 over 7, negative 2 over 7. Therefore, the angles alpha, beta, gamma, okay, I will just rewrite it in factor notations instead of 1 by 1. This is cosine inverse of 6 over 7 for alpha, cosine inverse of 3 over 7 for beta, and cosine inverse of negative 2 over 7 for the gamma. By the way, you see cosine inverse of negative means it is it's obtuse. You can use your calculator. Greater than 90 degrees, right? But when we talk about directional angles, theta, gamma, if the gamma is greater than 100, greater than 90 degrees, it means the angle is, the coordinate is below xy plane. Okay, it is below xy plane. As you can see here, the negative 2. Okay, it's below xy plane. Okay, let me go on. I think one question is enough for that part, huh? Okay, and then number 39 to number 44, find the scalar and factor projection of B onto A. Let's choose one of them. Let me do number 42. Number 42, factor A is negative 2, 3, negative 6. Oh, yeah, the length here is 7. And then for factor B, it's 5, negative 1, 4. The magnitude is 25, 26 plus 16. That's 42. Square root of 42. Okay, well, anyway, I don't know which one I actually need, but scalar projection of B onto A, that's actually component of B onto A, right? So imagine if this is factor A and this is factor B, the scalar projection is the length of this part here, quote unquote the length. The length is positive, if it is in the same direction of A, it's negative if it is opposite direction of A. Okay, now the factor projection is called projection of B onto A. Okay, now formula wise, this is A dot B over magnitude of A, right? If you remember. And we see what is A dot B, negative 10. Let me do it here. A dot B is negative 10 minus 3 minus 24. Oh, that's a big number. Negative 37. So this will be negative 37 over 7. That's the component of B. While the projection of B will be A dot B over magnitude of A squared times factor A. So this times here is not a dot product. Let me erase that to avoid that confusion. Negative 37 over 49 times negative 2, 3, negative 6. And if the number is that ugly, it's okay to just leave it like that. Okay, in other words, you factor the common factor out, and the common factor is ugly, right? What you may get confused, and please remember this, the formula. Notice that the screen, the projection onto will be the one dominant. The projection onto will be the one that you see everywhere. Okay, and the one that the factor you project from shows up only once. Okay, now that helps you. I hope that helps you to memorize. You will see these questions a lot though. Okay, so get used to it. Notice that I actually don't need to do this, huh? Okay, just in case I reverse the question, find the component of A onto B, then you will need that magnitude of B on the denominator. Okay, let me go on a bit more. Show that the factor or orthogonal of B onto A, B onto A is equal to factor B minus the projection of B onto A. So basically what they want us to do is, it's kind of hard to read it. We want to show that orthogonal of factor B onto A is perpendicular to factor A. Okay, knowing that definition of orthogonal B onto A is B minus projection of B onto A. Now let's take a look on the picture first. Why this is true. Okay, why this is true. Now that's factor A and this is factor B, right? Now then the projection of B onto A is this factor here. This factor here. Oops, why it disappeared? It's this one. Okay, this is projection of B onto A. Okay, now think about if I catch that projection of B onto A, this guy here, right? Subtract that from factor B. So let me copy, paste. Notice that B minus projection of B onto A will be this guy, which is perpendicular to factor A. Okay, that's the geometric geometric explanation. How about showing that without pictures, which is actually more the one that they want? At least now you understand what actually happens, right? But without pictures, how do we explain it? Then we go on. We need to show this, right? Proof. Two factors are orthogonal if the dot product is 0. So let's replace that orthogonal by B minus projection of B onto A Okay, that's equals to orthogonal, right? Okay, now do the dot product. The dot product of B minus projection of B onto A, dot that with factor A. Okay, we want to show that this is equals to 0. Okay, this is B dot A. Remember the distribution property minus projection of B onto A dot A. Is it right? And then this is equal to A dot B by commutative property minus what is projection of B onto A? That's A dot B over the magnitude of A squared of factor A dot A. But A dot A is what? A dot A is the same to the magnitude of A being squared, right? Notice that we end up with A dot B minus A dot B, which is equals to 0. Okay, then from there we see that, hey, you know what? They are actually perpendicular. From there, then we say that consequently, the orthogonal factor B onto A is perpendicular to factor A. That's the end of the proof. Number 50. This is into physics. A tow truck drags a stalled car along a road. The chain make the angle. So this, let's say this is the car that is stalled. Okay, and then you pull it with a chain. Okay, that forms 30 degrees angle to with the road. It's 30 degrees here. Now the tension of the chain is 150 Newton. What is the work done? The work equals to the magnitude of the force. In this case is 1500 newtons, and then multiply by the distance times the cosine of the angles. In this case is 30 degrees. So we have 1500 newtons times 1 kilometer, which is 1000 meter, cosine 30 degrees. Okay, so that will be 15 two zeros with 3 zeros times radical 3 over 2 joules. That's 75,000 radical 3 joules. Okay, so one big application of dot product actually in physics, actually into work. If the direction of the car, the stalled car moving, and the force applied to it is not parallel. If they're parallel, then the cosine of the 0 degrees will be just 1, right? Okay, now number 53. Again, you notice that this is an odd number. So I usually don't do that. If I do, then you know that these are an important question. Okay, now our main focus will be to develop this formula. Okay, that's our focus. Now, how to use that formula? Well, since you already have the formula, you can just use that, right? Okay. Now, let's see first. Notice that we have the question, show that the distance from a point P1 given by x1, y1 to the line ax plus by plus c is given by this formula. Okay, so suppose we have a line. Oh, no, not this one, sorry. Suppose we have a line and we have point P. So let's call this point P1, x1, y1. And this is the line L given by ax plus by plus c equals 0. Now we have learned from earlier question that this line here is perpendicular to the normal factor AB, right? Imagine you have ax plus by equals to negative c, right? So it's perpendicular to factor AB. Now, if I depict that factor AB, I'm trying to give you a better view of the graph. Let's say this is the factor, normal to it. I don't like the color though. Let me change the color. Otherwise it may be confusing. So this is the factor, normal to it, right? Call this factor N. Now we want to find this distance here. Let me use this color. We want to find this distance here. Okay, we want to find that distance. What we can do is let's create one factor from line L to point P. Now the thing is, we don't know which. If we already know this point here, the point right under P1 on line L, the projection of P1 on line L, then we can just find the distance using distance formula, right? But we don't. The problem is we don't have that coordinate here. We don't know. What we will do is we will create or use a random coordinate on line L. Let's use this point here. We don't know what point is that. So just call that P2, X2, Y2. Actually, X0, Y0. Call that P0 then. And we will get this factor. Okay, we'll get this factor here. Notice that this factor from P0 to P1 is actually x1 minus x0, y1 minus y0. Okay, that's the factor. Now, they give us a hint that we will use scalar projection. What do you mean by scalar projection? Now, try to take a look on this factor here. Notice that if I shift that here, right, then, you know what, let me just do copying instead of shifting. I copy that. Notice that the projection of this factor onto n will be the component of that factor onto n will be the length that we are looking for. Okay, in other words, let's call this vector v here. Okay, this is also vector v then. Okay, then the absolute of component of vector v onto vector n is the distance we are looking for. Okay, which is equal to absolute of, I use absolute because component may be negative. Okay, absolute of vector v dot n over magnitude of vector n. That's the absolute of, what is my v? X1 minus x0, y1 minus y0 dot n, which is ab, over square root of a squared plus b squared. Now at least you see the denominator already what we have, right? Right? Okay. Oh, it's just about the top now, how we play around with that. Let's go on. On the top we have, if I do the dot product, I will get a times x1 minus x0 plus b times y1 minus y0 in an absolute sign for square root of a squared plus b squared. Distribute the numerator. I will rearrange at the same time. That will give us a times x1 plus b times y1 minus a times x0 minus b times y0. Okay, which I will rearrange as I will rearrange as this. Notice that a x0 plus by0 plus c equals 0. If you use coordinate x0, y0 into that equation, right? Well, the coordinate t0 is on the line, so it must satisfy the equation of that line. In other words, negative a x0 by 0 equals to positive c. And that's the proof. Okay, imagine if you solve you have negative a x0 minus by0, you get that's positive c, right? So that's the proof. That's the proof. I'm sorry. Now, then how to answer that question? We already have the formula, so how to answer that question? What happens if you have coordinate 2, negative 2, 3 in the problem? Then distance from coordinate negative 2, 3, is it negative 2, 3? Yeah, negative 2, 3, and the line 3x minus 4y plus 5 equals to 0. If we want to find those distance, the distance between this point and the line is given by, notice that on the numerator, I have the absolute of that equation, but you will replace the x and the y by the x and the y of the coordinates. Okay, 3 times negative 2 minus 4 times 3 plus 5 over square root of 3 squared plus negative 4 squared. Yeah. This 3 here is from here. This negative 4 here from here. These are the same number. The 2, 3, negative 2, 3 goes here. And the negative 5, the positive 5 from here. Okay, so you memorize the formulas, you memorize the pattern, that will be nice. Now, unfortunately, this formula here is for two-dimensional coordinate system though. We cannot use this for three-dimensional coordinate system. Okay, as you will see in later part when we go over 12.5, then you will see another formula, very similar. The formula will be very similar to find the distance between a point and a line. And also, you will also have the distance between a point and a plane. Okay, let's compute this first. This is absolute of negative 6 minus 12 plus 5 over 5. Negative 18, so it becomes negative 13. That's 13 over 5. So that's 2.6. Okay. Now, one of the weakness, I will go to the next question. One of the weakness of my teaching is I don't do enough proofing. And you will see, I don't really ask proofing. As I remember, I don't ask proofing question in this class. However, I still need to train you to learn how to prove through examples. Okay, now one of very well-known inequality once you go to much higher level later on is what we call the Cauchy-Schwarz inequality that says the absolute of the dot product is less than equals to, or the dot product of two factors is less than equals to the product of the magnitudes of those two factors. But this question is actually very easy to do. From the definition proof, we know that A dot B is equal to the magnitude of A times the magnitude of B times cosine theta, right? So when I do the absolute sign, that's a product of the magnitudes. Well, the magnitudes of two factors are non-negative, right? Times absolute of cosine theta, right? If there's anything make dot product negative, it must be the cosine theta. Now, however, at the same time, we know that cosine theta is less than 1, less than equals to 1. Okay, so now we prove that. Let me write it down. Since absolute of cosine theta is less than equals to 1, then we have that inequality. So this Cauchy-Schwarz inequality is actually easy to prove. In this case, you will see when you go a much higher course, linear analysis, linear algebra, it may not be 3-dimension, maybe multiple dimension, and the meaning of the norms may be different. Like the norms we have here is the idea of Pythagorean theorem applied twice in 3-dimension, right? But in general, the word norms may mean different cases later on. Okay, now then let's go on to last question that I want to go over here, number 62. A bit tedious. Give a geometric interpretation of triangle inequality. Well, as we learn, triangle inequality basically says that the distance, the length of one side of a triangle is always shorter than the sum of the other two sides. So side A must be shorter than side B plus C. Okay, side B is shorter than side A plus side C, and side C is shorter than A plus B. In the context of our daily life, maybe a direct distance between one point to another point always shorter compared to if you need to stop by somewhere else first before you go home. Now, I hope this explains why, of course, jokingly, this explains why I sometimes not happy when my wife asks me to go stop by somewhere to buy her something before I go home, when I really want to go home. Okay, because what? At least from the distance point of view. And if you think about time, of course, then the time it takes for me to go home directly will be shorter than if I need to stop somewhere else. So it's not only about the distance that I need to drive or I need to walk, but also the time I need to spend more because I need to stop by somewhere else first. Okay, that's the geometric interpretation. Now, but how about proving that inequality? That inequality basically, if you have factor A plus factor B, which is factor C, right? Let me kind of like do that interpretation. Factor A plus factor B is factor C. Then show that factor C is less than equals to the magnitude of factor A plus magnitude of factor B. That's what we need to show. Yeah, of course, you cannot say, oh, you know what, we learned triangle inequality in the past, so just use that. No, the idea here, can we apply triangle inequality using factors? Okay, now let's start. The idea is as follow. So if I have factor A plus factor B, the length of that, we know that will be at least 0, right? Now, this at least 0 is actually an important argument we need later on. Let me just put it there for now. Okay. Therefore, if I square both sides, of course, the magnitude of factors A and B will still be at least 0, right? But at the same time, we know from one of the property we learned before, the square of the magnitude equals to the dot product unto itself of that factor. Okay, I think the one we saw was like magnitude of factor A squared equals to factor A dot factor A. That's what we have before, right? So if your factor now instead of A now becomes A plus B, then we will have A plus B dot A plus B. And then we will use distribution property. This is A dot A plus B plus B dot A plus B. I will apply that further. This is A dot A plus A dot B plus A dot B plus B dot B, which is, notice A dot B, I'm sorry, it should be A dot A, huh? That's A dot A. Now this is magnitude of A squared plus 2 times A plus B, 2 times A dot B, I meant, plus magnitude of B squared. Okay. Now, A dot B may be negative, may be positive, but And this is definitely at least zero, right? This may be positive, may be negative. So let's make it guaranteed positive. What I will do is I will apply absolute sign on the A dot B. That way it makes it positive. Okay, now then we use the Cauchy-Schwarz, the one we have above, that magnitude of absolute of A dot B is less than the product of the magnitudes. So you will see here, this part here, I make it 2 times the product of the magnitudes. Which is equal to absolute of A plus, magnitude of A plus magnitude of B being squared. Okay, therefore, when I go back to, if I do the square root, right, because it's positive though, because it's positive, and therefore this is also positive, when you apply the square root, okay, I'm actually referring to not that one, I'm referring to this. This is positive, this guy is positive here. So when I apply the square root to this, recover that magnitude of A plus B, I will still get a positive part. Okay, in other words, 0 is at least is less than equals to the magnitude of A plus B is less than equals to the virtue of this. When I apply when I cancel the square, that's absolute of A plus magnitude of A plus magnitude of B. Notice that it cannot be negative. I mean, this guy here will be at least 0 anyway for each of them. Okay, now that guarantees that the magnitude of the sum of two factors is less than equals to the sum of the magnitudes of two factors. And that's the end of that proof, which also end our discussion on problems from section 12.3.